Hello everyone, we are Group 1 from EMM4716, which is course name for System Modeling and Analysis. So we have two group members in our team. First one, myself, Bong Shai Kit, metric number 180238, and the second member is Woon Yong Kang, 176482. So we were being tasked to give a brief presentation on the solution example of linear programming on the idea of maximization. So before we get started towards the whole solution on the example, let's just give a brief understanding about what a linear programming is. So typically linear programming is existed just to optimize a certain scenario we have in our lives, whether it's about profit making or whether it's about to optimize about our expenditure. So typically there will be a lot of parameters involved in optimization of a certain scenario. For example, the resources you have, for example, or any other matters in the hand, right? But the very factor that you have to keep in mind is that in linear programming, there will be only two unknown parameters can be involved. Normally, we call it as x and y, because linear programming typically just to solve a very simple question. So we'll move on to the first question of today's presentation. Alright, so let's take a quick look about the first question that we want to present to you, right? So this question, typically the summary of it is that we want to help this farmer to maximize the profit he can get from the types of plant he has and for all the constraints he has in here. But before we go further into understanding the whole situation, we can have a quick read about this. But how do we know whether this question is for maximization or minimization under the understanding of linear programming? Very simple, we can take a quick look at the very last sentence in this question, which is, what is the maximum profit? Meaning that this question wants us to help the farmer to obtain maximum profit, meaning in the end, we want to use the idea of maximization in linear programming to solve this question. So let's take a quick look about the solution we have here. So like I mentioned, objective function is to find the maximum profit for the farmer. So this table, typically, it gives you a very brief understanding about the whole situation here. This is a summary of the whole question. So we have two types of plants that the farmer can plant. First, wheat, and second, barley. So there are several other parameters involved in this problem as well. So first thing, we can see that the idea of profit, meaning that how much he can make based on the plant based on the plants he planted. So in this question, every single one arc of land gets to produce a profit of $5,000 for the farmer. While you have one arc of barley planted, you get a $3,000 total of dollars for profit. So this is the very first summary we can get. Secondly, we can see the idea of pesticide. For every one arc of wheat a farmer plant, he required 2 gallons of pesticide to be planted. For every one arc of land of barley planted, he needs 1 gallon of pesticide. So that's the second idea you get from this question. Third thing is about the constraints we have on over pesticides and land. So we can, based on the question we have read, that the pesticide total of only 10 gallons is permitted by the government. So that's the first constraint we see from here. And second constraint we get to see is that the farmer only has 8 arcs of land to plant wheat or barley. So this is a summary. Ultimately, what we really want to know from this question is that what's the quantity of wheat and barley to be planted in order to get the maximum profit, right? Which is why wheat and barley will be the unknown parameter here. Which is why we're putting x and y, x for wheat and y for barley. So that's the general understanding about the question. So from there we can form an equation, an objective function for the whole problem. The maximum profit to get for us, we determine the objective function as z. So z equals to 5,000x plus 3,000y. So why do we write so is because for each arc of land of wheat you get $5,000, which is why 5,000x. Meaning that let's say x is 2 arc of land, you get a 10,000. Because of 2 times 5,000, you get 10,000. So the same thing goes to 3,000y. So that's how we get the function, the objective function for this whole question. But on every single objective function we have for linear programming, we always have the sort of constraint as mentioned, right? So how do we make the constraint as a formula? So first of all, we have to write subjected to the constraints. So the very first constraint we can see here is the land constraint. The land constraint, as I mentioned, is that the farmer only has 8 arc of land to plant, right? So since one arc of wheat and one arc of barley can be planted like based on the question, which is why we have x plus y is supposed to be less or equal to 8, maximum of 8. So on the second constraint is the pesticide constraint. We have every one arc of land of wheat, you need 2 gallons of pesticide, or 1 gallon of pesticide for one arc of barley. So which is why we have 2x plus y has to be less or equals to 10 gallons of pesticide as we have set as a constraint. So last thing, there are two extra constraints here which is considered as sign constraint, meaning that for the number of wheat and the number of barley you have to plant, the number has to be at least 0 or more than 0, meaning that it can't be a negative value for it because you can't plant a negative number of a wheat or barley, which is why we have all the constraints set based on this summary.
After we figure out the objective functions and all the constraints, we actually can start to draw the graph based on the information collected. So here's the graph that I draw. So before you can start to draw a graph, you need to transform the inequality signs in the constraint equations to equal signs, because so that we only can use these two constraint equations to draw the line on the graph. So as I say, I first transform the inequality signs to equal signs, and then I draw these two lines. This line is for the pesticide constraint, which is 2x plus y equals to 10. Yeah. And then this line is for the length constraints, x plus y equals to 8. Yeah. As you can see, I transform the inequality signs to equal signs so that I can draw the lines. So after that, we need to find out where is the feasible regions. Since the constraints demanding for less than and equal to, so from this point we know that the position of the feasible region is actually located below these two lines. So here, the only region that fulfill this condition is these regions which are shaded here. So this one is the feasible regions. Then for us to more easily to locate the position of the feasible region, we can use some alphabets to denote the corners of the feasible regions. Yeah. For example, like what I do here, I use the alphabets A, B, C, D to denote the corner of the feasible regions. Yeah, like shown as shown here. So after that, we need to find out the coordinates of these points, so that we can fully know the locations, the position of the feasible regions. So from here, according to graph, I can actually know the coordinates of the points, and then I already listed the coordinates of the points. Other than using the graphical method to identify the coordinates of the points, we actually can use another method, which is a more accurate method to get the coordinates of the point, which is the simultaneous equation method. Yeah, like what we usually do. Yeah. So we need to figure out the coordinates of each of the point. For A, before we can do that, we actually need two intersection lines on the graph so that we can locate the coordinate of the point. Yeah. So for point A, the two lines involved in finding the coordinate of point A is actually the y-axis and the length constraint line. Yeah. So by using these two lines, we can actually find out the coordinates of point A. Same goes to other point. For point B, is a little bit complicated compared to point A because it involves the constraint equations in finding the coordinates. So the two equations that can be used for finding the coordinate of point B is the x plus y equals to A and 2x plus y equals to 10, which is the constraint equations that we stated just now. So after we figure out all the coordinates of the points, we can substitute the coordinates of those points into the perfect equation that we used just now. Yeah. So I already do that part over here. Yeah. We substitute one by one the coordinate into the perfect equations and to see which one can give us the maximum profit. So as stated here, the maximum profit can be obtained when we substitute point B into the perfect equations, which indicates that 2 arcs of wheat and 6 arcs of barley. Instead of using the simultaneous equation method, we can actually use the method of drawing as a perfect line. So for this method, we actually need to randomly pick one point from the feasible region and then to substitute the point into the perfect equations. Why we need to do so? Because we need 2 points to draw the isopropyl line. So we do so to get the coordinate of the second point. So this one is the first isopropyl line that we draw, and then after that we need to draw the second isopropyl line, which we use to locate the best solutions from the graph. So from all the justifications that we did just now, we know that the maximum profit point is actually located at point B. So in conclusion, the farmer needs to plant 2 arcs of wheat and 6 arcs of barley in order to get a maximum profit of $28,000.